So now that we've got our application signed and ready to be deployed, we're still going to want to look at one more thing here, which is securing the application. Now, one step that we neglected when we did the signing and when we did the export from Eclipse was obfuscating our code or securing it in any way. What we're going to talk about right now is a tool called ProGuard, and what it basically is a code obfuscation tool. If you're not familiar with code obfuscation, basically it's the idea that you would take some code that both Java and .NET basically have like a bytecode or a lower level of code that gets interpreted. And that code has a lot of information still, like your class names and method names. And so this code obfuscator, the idea behind it is basically to take that code and those names and kind of mangle them so that it still produces the same output, but it's very hard to discern what the logic or the naming of the original classes and methods were, and it's very hard to follow. So it'd be very difficult for someone to decompile your code and then figure out what your code was doing and modify that. So ProGuard is actually an open source Java tool. It's been built into the Android development toolkit in Eclipse, and it's really actually easy to use inside of Eclipse for basic usage of it. And what it essentially is going to do is prevent someone who decompiles your code from getting much meaningful information. So why should we use ProGuard? Well, if you have some sensitive security inside your code, like for example, you have some password or sensitive data or an algorithm that is proprietary or anything that you'd want to protect, assume that when you put your application out there, someone can decompile your app and look at your class names and methods and algorithms. Just you have to assume that because it's so easy to do today. It's very easy to decompile Java code and .NET code. If you're familiar with the tool, the .NET tool Reflector, if you've never used that tool, you might want to check that out. But basically, you can just point it at a DLL, and you can generate C# or VB.NET code from that DLL. That is pretty accurate, and we'll show you exactly what that code is. So very easy to decompile code. Same thing with Java. Apps are pretty easy to pirate. So even we're going to talk about a tool that Android puts out called the Android License Manager, and that helps protect your application. But that's not even enough, because you can put some code in for your license manager, for your application to use a license manager, and someone can just get your app, decompile the code, change the flag that calls the license manager, that checks the license, so that it doesn't recompile your code, and then they've got your app. So by using ProGuard to obfuscate your app, you're going to make it harder for someone to decompile and do that. So now it's going to not prevent them completely, but it stops you from being an easy target, which is key because it's going to make it a lot less likely that someone's going to invest the time that's required in order to crack your code. And just so we're being completely honest here, if someone is determined to decompile your code and crack it, it's very, very, very hard to prevent that from happening. By using a tool like ProGuard to obfuscate it, you're going to make it so that the effort for them to do that is very high. So it's really more of a deterrent than anything else. But it's definitely something that we can do very easily to secure our code a lot better. And then one added benefit that we're going to get with this is it actually reduces the code size. When we look at this more in depth, you'll see that it actually strips out some of your code that's not being used that was inside of your jar. So when not to use ProGuard? Well, you don't always want to use it. Some experience that I've had is that ProGuard is pretty difficult to configure when you have a lot of external libraries, especially if those external libraries do anything special with reflection or something similar like that, using advanced language features or using attributes, some kind of late binding, things like that. You can still use ProGuard, but the configuration might be pretty difficult, so it might not be worth the effort. Also, it's a little bit harder to debug after being deployed because if you can imagine, when you get a stack trace from a user, that stack trace is going to have the mangled names. Now I'll show you how there's a mapping file that you can use that can make it so that you can interpret that stack trace, and there's a tool that will convert that to your plain English classes and method names. But sometimes it's just not going to be worth using ProGuard, and there are some disadvantages to it, just so you're aware. So let's go ahead and take a look at how the basic uses of ProGuard using Eclipse. So there's two files here that we're going to look at in regards to ProGuard inside Eclipse here. The first one is this default.properties file. It'll be a default file that's created when you create a new Android application, a new Android project. And what you'll want to do here is basically just add this line that will give you, or will cause the application to use ProGuard. It says not to change this file, but in reality, in order to add ProGuard, you do have to change this. So I'm not sure why it says that, but if we add this ProGuard.config equals ProGuard CFG, then we're going to tell Eclipse to look for a file called ProGuard.cfg inside our project and use that for the configuration for using ProGuard, and that will cause it to use ProGuard actually. So I'm going to save this default.properties, and let's take a look at that ProGuard config file. Now, we're not going to go over all of this here, but you can kind of look and see what's going on here. These are all the configuration options. ProGuard's pretty complex as far as configuration, but luckily Android gives us a default configuration for it that works for Android. Some of the things to look at here is that it keeps some of these classes from being mangled, which is required. Otherwise, you would have some problems. So if you add more classes to your application, you may need to do this, or if you add external libraries, this is where it can get a little bit complicated. It does some commands here like to keep classes with a certain member name, and it keep class members of enum, and it's got a few things here that's going to prevent certain things from being mangled, where Android is going to use reflection and things like that, where it's going to have the right name in order to work correctly. So there's really not much that's required other than what we've done already, which is just adding that one line. Then what we're going to do is simply just go in here and we'll click export, and we'll just do export Android application. And I'm showing you the other way to do the export here. When we did the export the first time, we had done it through the Android tools, but this is the exact same thing, just to show you another way. And it's the exact same steps. We'll just go right through here and use that existing key store we had created before. And just put test key store. And then we already actually have a file there, which is fine. We just click finish. It takes about a second longer for it to do the ProGuard, and there's not really a good way that we can tell looking at the file here, but it is obfuscated. But what we can do is we can look at the project and we can see that it's generated some output, and that'll give us an idea. So if I go and find our workspace here, go to Protein Tracker, you'll notice this directory underneath your project that's called ProGuard now. And if we go into here, we've got a few files here that ProGuard has created when it obfuscated our code, when it ran on our code. So the first one is this dump.txt file. And this describes the internal structure of our file. So if you look at this, there's a lot of information here, but it is basically going to show you what methods and what classes are inside your entire application. Quite a bit of information. The next file is the mapping file. And what this one does is it maps the old class names to the new class names. So you can see here that we've got our main activity. It's still mapped to main activity, but we've got an integer here, reset dialog. It's now called A. And we have this help button listener. It's now called B. and reset button listener is now called C, and so on and so forth. So you can see how it's mingled our code to make it a lot more difficult for someone who decompiles it to understand what it's doing. And it also provided us a map that we can use to figure out, see through an exception. Oh, okay, that's the reset button listener. And then the next file is the seeds file. And what this file does is it shows us things that were not obfuscated. And so we've got these 4 classes here that were not obfuscated. And then we can look at the usage file. And that was code that was stripped because it's not used. This is kind of useful to look at to know what has been pulled out. And we can see there's a lot of the R stuff here that was pulled out that was not used, these types inside here. And so that's really all there is to ProGuard. There's a tool that we can use when we get a dump file or a stack trace and we can map it back. I'll show you that real quick. So that tool is going to live inside of our SDK. If we go inside our SDK and then we go to Tools and then ProGuard, and inside this directory we should have a tool. In the bin here, we have a retrace. And what this does is this will start up a command that we can pass into here the name of our map file, and then it will decode that and give it in a stack trace, and it will decode it and give us the stack trace in English that we can read and then look into our code. So we're not going to go over using that right now because we don't have a stack trace, and it takes a little bit longer than we have here. But if you need to do that, just remember that you have this retrace tool in here.